Hi everyone and welcome back. In this video, I'm going to walk through an example of taking an argument in verbal form, turning it into symbols, and then turning it into a truth table. After that, we'll evaluate whether it is valid or invalid. Alright, so let's look at this argument here. If I turn in my homework, or just my work, if I turn in my work on time, I will pass the class. I didn't pass the class, therefore I didn't turn in my work on time. Okay. So our job is to figure out whether this is valid or invalid. So let's just symbolize it. First, this is an if-then statement, right? So this is if I turn in my work. So if, and then I'll put an arrow, then I pass the class. And that W should be capitalized. Okay, so if W, then P. I didn't pass the class. That's another way of saying not P. Therefore, I didn't turn in my work on time. So that's not Q. Or not W, sorry. W. Okay. Now that's great. Premise 1, premise 2, conclusion. I have two variables here, W and P, and I have three premises, so let's just start writing the truth table out. So the way that I do it is I write the variables out first. So my first two columns here are going to be my variables. So I usually label them variable 1, variable 2. In this case, I have W and I have P. And then I like to label the next few parts as my premises and my conclusion. So this would be premise 1, this would be premise 2, and this is my conclusion. So premise 1 is that if W, then P. So what I can do if I want to, I can just copy it and paste it. And I'm using the shorthand for the arrow, but the arrow is a symbol you can find online. And then premise 2 is not P. And then the conclusion is not W. Cool. So I have my variables, I have my premises and conclusion. What I like to do just for like the visual of it, I like to label this in some kind of different color, maybe gray, just to show the difference between the fact that this is a header, just to explain what that is, and then the variables and the premises themselves. All right, let's jump into it. So you have two variables, which means you have four possible outcomes. You have one where they're both true, true, true. You have one where the first is true and the second is false, where the first is false and the second is true, and then when they're both false. Right, those are the only four ways the situation can happen. That's why we do it this way. And now we go to premise 1 and we look at if W, then P. So this is just knowing the truth condition for the conditional. So the only time this statement is false is when the antecedent, W, is true, but the consequent, P, is false. All right, well, we can see that they're both true in this first row, so true. The second row, we have the antecedent is true, but the consequent is false, therefore it's false. And then in the final two, we have the antecedent is false, which means the entire conditional is true. If you're not comfortable with that, it means you have to review your conditional truth conditions. Okay, not P. Well, that's just the opposite truth value as P. So if P is true, false, that means it would be false, true, right? Not P just means take the opposite truth value of P. And then not W, same thing. I look at W and I see true, true, false, false. That means I just go false, false, true, true. Now what am I doing? I'm just flipping the truth values of W to get not W. Okay. I have a truth table all filled in. What is it actually showing me? What does it mean? So I'm trying to find invalidity, whether it's valid or invalid. If it's invalid, I can point it out in the truth table. If it's valid, I can point that out as well. So the question is this argument valid or invalid? Well, The definition of invalid is that the premises are true, but the conclusion is false. So we have to look at our truth table and we have to see, is there a place where the premises are true, but the conclusion is false? So we have one premise is true, but this one's false, so we don't have a case where both premises are true. In fact, the only case is this last row right here, where the premises are true. Now we have to ask ourselves, the premises are true. Is the conclusion false? No, the conclusion is not false. So if premise 1 is true, premise 2 is true, and the conclusion is true, that makes the argument valid. So if this conclusion was false, then it would be invalid. Because remember, invalidity means true premises that lead to a false conclusion. That's what invalidity means. In this case, we don't have that. We have everything is true premises and a true conclusion, so we are good to say it's valid. So that's the crux of it, making sure you know how to read the truth table once you complete it. The best way to think about it is, where are the premises true? And that's why you just identify them. And then if the conclusion is false, it's invalid, even if it's just one instance. And if everything is fine, like this, where it's true, then it's valid. So that's the example of taking the verbal argument, converting it into symbols, and then taking that symbolic breakdown and putting it into a truth table. Great. Hope that helps. Let me know if you have any questions. Thanks.